Hi everyone, welcome back to our channel. Today we are going to learn how to interface push button or switch with the PIC16F877A microcontroller. If you are new to our channel, please subscribe to press the bell icon so you will never miss our latest videos. To interfacing the switch with PIC16F877A, the switch is connected to an input pin such as port B. The microcontroller continuously checks the status of this pin. When the switch is pressed, the input changes. The controller detects the changes. The program executes the required action. Turn on LED, start a motor, activate buzzer, or display a message on LCD. Practical example: when the switch is pressed, LED is turned on. When the switch is released, LED is turned off. This is one of the first experiments every embedded system students performs. A real-time industrial example: imagine an automatic conveyor belt in a factory. An operator presses the start button. The PIC microcontroller receives the inputs and starts the conveyor motor. When the operator presses the stop button, the controller immediately stops the motor. The same switch interfacing concept used in industrial automation. Another real-time example: consider a home doorbell system. When someone is pressed the doorbell button, the switch sends the signal. The microcontroller detects the input. The buzzer activated. So here also, now I want write for one code, pressing the button, that time write the one GPIO LED. Okay, so now I go to MPLAB XIDE. Already I opened in MPLAB XIDE. So I want to create now new project file, new project, microchip embedded. Then I click it next. Then I selected for microcontroller PIC16F877A. 877A. And anyway, this microcontroller is not available. 177 PIC16F877A. Okay, it's mentioned for F77A. Okay, F877A. Then click it on next. So here you can select for XC8 compiler. Again, click for next. Then you can select for project name. Then first you can select for project location, browse. Then go back. EDU product lab, PIC16F877A English, then program. Inside LED on, LED blink also is previous section. Now I want write for here only third project file. So I want write it in third dot switch positive logic. Okay, switch positive logic, SWITCH underscore positive logic, PL. So positive logic mean I mentioned for positive logic. That project is also added in PIC16F877A English, not program. So 3 dot switch positive logic. So I want now finish. So the switch positive logic file is created, done. So I want click it for source files. The source files downside nothing file is created. So I want right click, then new, click on main.c. So here is file name is new main. So I want to remove it new. So I want to use for only main.c. So extension.c is already default condition. So extension.c you can mention for main. So it is after that you can click it finish. So main.c file is added, is done. So after that you can write it in program. So main.c I write it in as include xc.h void main return. This function only is there. So I want to write it for tris b equal to 0x00, tris b equal to 0x01. So 0x01 mean I want to use it for RB not pin is input. So I got write it in table on 8-bit register. Wait 2 minutes. I will write it in one register. Okay, this is a 8-bit register. This is LSB bit. Okay, LSB. This is MSB bit. Most significant bit and least significant bit. This is bit RB0, RB1, RB2, RB3, RB4, RB5, RB6, RB7. So I want to write it in one pin. RB0 is input. All other pins also output. So tris B and port B. Tris B is input direction or output direction. You want select one mean it is input direction. You can set it value is 0 mean it is output direction. So that LSB value RB0 is it is for input direction. That bit register value is 1. So 2 power n, formula is 2 power n, that bit value is 0, that bit value is 0 mean here 2 power 0, anything power 0 value is 1. That's why I selected for 0x01. So I need for initially that pin is high or no, high or low. So I want write it in low state. That's why I will write it in low. So port B equal to 0x00. So 1 minute I will close this window. So I close this windows. So here I will click it end of line semicolon. Then port B equal to 0x00. Port B equal to 0x00. End of line semicolon. Again while of 1. I need for super loop. So while of 1. So this is for case sensitivity. So you can write it in small letter while of 1. So while of 1, open open curly braces and close curly braces. Once you can open curly braces, press enter mean automatically it came for close curly braces also. So this RB0 is input. So RB0 pin is input. So you can write it in if RB0 open bracket close bracket. You can remove this sketch mark. I want to remove it, this one. So RB0. So if condition open bracket RB0 equal to 1. So today we are discuss about the positive logic program. So I want to write it in code in positive logic. Positive logic means you can write it in pull down concept. So pull down concept means you can press the switch, controller receive the 5 volt. So 5 volt means controller understanding for 1. So microcontroller understanding language is binary language, so 0 to 1. So understanding language is binary language, so 0 to 1. It is you are pressing switch means it is controller received 5 volt. So it is understanding 1. Okay, controller is receiving 1. So now I want to write it in here. I want to use for RB7 is output pin, output LED. So RB7 equal to 1. Pressing any switches, that time RB7 pin is low. So I want to write it in RB7 equal to 0. So that condition I want to write for else statement. So okay. So else. So else also case sensitivity. So I want to write it in else in small. Open curly braces. Then end of line you can write it in close curly braces. So this line I need for a readable format. So I want press for tab I key. So now is readable format I want selected. So now I want compile this project file for protection build main project. So the any error is there mean here is showing, otherwise is build successfully only showing. So build successfully, everything is completed. So here is hex file also generated. So I open to Proteus file, Proteus 8 proportional. Okay, you want Proteus file or anything, you can command it in my individual chart. Otherwise PIC16F877A English WhatsApp group is there. You can join it and ask for questions. Okay, now I want to create for new Proteus simulation file, new project. Please wait for 1 or 2 minutes. It is showing for name new project wizard. So you can click it on from development board. So path this you can select for browse. Go to your local disk D, my files, edu product lab, PIC16F877A English, then program, switch positive logic. Then here you can type it, select folder, okay. Then Arduino underscore 168, you can change it to file name, switch positive, SWITCH underscore positive logic. Then click in finish. You can open the new window. It is some circuit diagram also is there. You can select it and delete the diagrams. Okay. Now here you want mean you can leave it. Otherwise you want new components. These components I don't want mean you can right click that components you can select, then right click, then delete. Again button is needed, so I want not remove for buttons. LED yellow also is needed, resistor is also is needed, so I don't remove for these components. So I want click it for components mode icon, then press the bell icon. So I want here press the PIC16F877A microcontroller. I am using for PIC16F877A microcontroller. So here PIC16F877A. I click it in PIC16F877A. So you want a button mean, you can type it in button. Okay, button. Button mean it is showing for button. I want double click mean it is updating. Okay, yes or no mean it is yes. LED yellow also you can type it for LED hyphen yellow. Okay, here is showing for LED yellow active animated LED model. We want resistor mean you can type it okay, RES. So here is scrolling down mean it is blue color mark, it is resistor. Okay, you want double click mean it is updating. Okay, every comments I will take it in PIC session of a Proteus library. So I want first I will collect it in PIC session of 877A. RB0 is input pin, RB7 is output pin. This blue color box only you can keep it your components. So now I want write it in input button. So I want connect for buttons. So here I want connect to one button connected to directly RB0, then resistor connected to ground. So this is pull down concept. Anyway, you can press the switch, controller is getting 5 volt. You can not pressing switch, that time controller is getting 0 volt. Now I want connected to LED yellow. LED yellow also RB7. So now I want connected to everything is correctly. So I want now doing for power and ground. So you can come to terminal modes. You can count it every commons icon 1, 2, 3, 4, 5, 6, 7, 8. These terminal modes you can click it power and in ground is the power icon you can take it, then place it in top of button. So I want keep it in here, then I will select for draw in power supply, then ground. I need for that resistor, then LED also both is needed for one ground pin. So I want commonly used for one ground pin, I take it for both. Okay, now I want load the program. First you can click it, double click in IC, then showing for edit components mode. This is the program file. So program clock frequency is defaultly set for 1 MHz. You can change it to 4 MHz. Okay, anyway PIC16F877A, it is minimum 0 MHz crystal accelerator to 20 MHz is supporting, but 1 MHz means it is very slow. That's why you can use for 4 MHz. Then program file you can click it. It is showing for switch positive logic file. So once I will verify it is PIC16F877A English program switch positive logic, then switch dist default protection switch positive logic .x protection .x. I will load it, then okay. Then I want play the program. That time program is running. So I want press the switch. So press the switch. LED is working. LED is turned on. I want release the switch. That time LED is working fine. So I hope you now clearly understand the concepts of how to interface PIC16F877A switch interfacing and push button interfacing. If this explanation helped you understand the concept, please subscribe to our channel and press the bell icon so you never ever miss our latest videos. Thank you for watching this video. If you have any questions, leave them in the comment section. Need help with final year projects, mini projects or IEEE projects, contact and WhatsApp. Don't forget to subscribe and press the bell icon. Okay guys, thank you.